Hello everyone, guys. I've just been trying to make sure that the stream has started. Um, yeah, I hope that the connection is great, that there is no lags or anything like that. Oh, I'm sorry. I'm sorry for you looking at this. Yeah, let's do some coding today. I decided to start from scratch. Actually, give me 1 second, please. Development, Odin projects, Odin projects. Okay. Okay, let it be the test project. Never mind. Yeah, I've been experimenting a little bit with some text editors. Uno. My cat is exploring my room. Yeah, so I've been experimenting with some text editors. I've prepared myself a Sublime Text for Odin. I'm quite happy with how it looks and goes and how fast it is. The thing that I haven't figured out yet is debugging. I think I will not be able to debug my program. But anyway, I think we will be able to attach currently running program to Visual Studio if we need to. Yeah, I decided that I will not do any Vulkan stuff. This stuff is very advanced, and I'm not really that sure that if I will be interested in that, I will do it in my free time and not on the stream. I think for the stream, I should do something more quick and something more interesting. Yeah, I will just start from scratch and um, we'll see how it goes. My idea is currently maybe I should start making some games which is something like Worms. If you're familiar with the game called Worms, it is a game where worms should kill each other on the map, which is destroyable. And yeah, I really liked such kind of games when I was a child, and actually back then there were not too many games that I could play on my phone. One of them was Worms. Also, we had in um, in CIS region we had um, a social network where there were many games, and one of them was Wormix, and I really liked that game. It was also like like Worms clone, but in the web browser where you could play with real people, and that was that was interesting. And actually, I'm thinking that RayLib will suit very good for that. Very good for such a game. Oh, I'm sorry. Because if I remember correctly, RayLib games could be run in web browsers. I'm sure there will be a lot of work to figure out how to work with shaders. And fortunately for me, I think I'm quite good at OpenGL programming, and I hope that my knowledge will help me to um, figure how this works. And so far, I really like the RayLib because it is very simple. It is very simple, and the API is great. Yeah. So without further ado, let's say import vendor RayLib, and let's say we will call it RL. Also, let's import this default package core format, core fmt. Nice. I think for now it will be enough. Yeah, let's just open the RayLib window. Window. How do I create window? Window should close. Init window, yeah. Init window. Let's create a constant. When the width. One second. Yeah, when the width. Let's say it will be equal 920. When the height will be equal 180. Okay. Let's call our window. How do we call it? What are the parameters? Give me 1 second. Width, in the width, in the height, and let's give it a title. How do we name the game? In the name. Let's do something like this. Nice. Let's close the window. Yeah, that will do it. While window should not be closed. We will update our game. Let's do the RayLib begin drawing. RayLib and drawing. Should I pass some parameters into here? I do not remember, but anyway, RayLib, clear background. Let's let's search for some nice sky color. Blue sky color RGB. 135. Oh, well. Yeah, I like this color. Okay. So the first thing is done. The first part. To be honest, I never made the progress further than that in RayLib. But yeah, let's see. As the next step, I think it will be great to load some image and display it as a map. I don't know what even to search for. Give me a second. What can we search for? I think it should be some image with some alpha, so that it is like not okay, never mind. Let's search for, I don't know. Mountains cartoon. Oh, I like it. I like those images. I think what we will be able to do is that maybe. Oh, I think I have a nice idea. I think I want to find something in higher resolution. No. That's better. That's better. That's better. Okay, never mind. Let's just save this image. It is JPG. Okay. JPG. I don't know how to pronounce it. Sorry. Mountain view cartoon. Okay. And what I will do now is that I will go to Photoshop. And I will open this image. I don't care too much about the quality of what I'm doing right now at the moment. Yeah. I just want to... Where is this image? Yeah, here it is. Okay, maybe I will clip it. Oh my god, why is it so hard to find nice one? Yeah. It's quite difficult to find something good. Never mind. Okay, what I will do now? I will wait. 1 second. Okay. Now, let me do what? drag it into here. You see, if I scale this image up, oh, actually it looks quite nice, I think. Yeah, I think this will do it. So, what I will do right now is I will use lasso tool to do something like this. I will just try to remove everything except those mountains and this landscape. Luckily for me, the image is quite easy to select. Okay. Nice, good job. So, what I will do now, I will remove this background and deselect, and I will try to save as gamedev project test project. I will create a new folder called res. I will create a new folder called maps. And I will call this one first map. And I will save as PNG so that alpha channel is exported. Okay. Very good. Very good. Okay. Now, let's set the max FPS. Set target FPS. Let's set it to 60, maybe. If we do not want, we can change it later. Yeah, okay. Showing. So now let's load the texture. I think RayLib should have something. Load image. Load texture. What's the difference between image and texture? Maybe. Interesting. RayLib cheat sheet. I found that RayLib has a nice thing called cheat sheet. I think it's really helpful. Load texture. Loading functions. Load texture from file into GPU memory. Into GPU memory. Interesting. And there is a thing called load texture from image. So I can load image first. And then I can load image first, and then just and then just make it to be a texture. I think image is something on the CPU which we can access and modify, maybe. Yeah. And I think this is a good idea. Load image. Let's provide it with the path res maps. How did I call it? First map. first map.png. Okay. Map image. Okay, sorry. RayLib image. Okay. Maybe there is a function called draw. RayLib draw image. Draw a rectangle. There is a thing called image draw rectangle. Oh my god. Image draw. Image draw rectangle. What does it do? Let's search for it. Image draw rectangle. Draw rectangle within an image. This means that I will draw to the image. Interesting. Interesting. Oh my god. How do I draw a texture in RayLib then? Interesting. Draw image rectangle. RayLib draw image. How do I do this? I should do unload image. Interesting. Okay. Unload image. Texture from image. Okay. Draw texture. Draw texture. Okay. I should just draw the texture. I have to convert it. I cannot directly draw the image. Okay, never mind. Let's actually RayLib unload image first. Map image. RayLib draw texture. How should we draw it? Okay. Map texture. What's coming then? Position x 0 0. Draw texture pro. I want to do it in world space, I think. I do not want to do it in the screen space, though. Give me 1 second, please, guys. Okay. Okay, let's just draw the image first. I do not want to care too much about how to do it. Just really white, I think. Map texture. What is map texture? Map texture. RayLib texture. And is equal to RayLib texture from image. Load texture from image. Let's unload this texture as well. Unload texture. Okay. Yeah. Nice. We have a nice map now. Good job. Okay. That's what I think wanted to see. I think. Now let's figure out how we can implement the camera, because I do not want this view to be static. I do not want to perform all calculations in the screen space. I do want to make it in the world space, and because I'm new in the RayLib, I'm new to the RayLib, I just want to figure out how they manage all this stuff in here. I think it will be good to know, so to speak. Okay, so let's see. In the cheat sheet, I've seen some things related to camera. Maybe we should create a camera first and do something there. Else 2D mode with custom camera. What 2D mode does? I'm wondering why there is not too much tutorials on how to use RayLib. Even no documentation as far as I can see on their official website. RayLib. Examples, games, cheat sheet, wiki. Platforms and the graphics. Okay, never mind. Okay, now we have this image, and that's great. Let's maybe search for some examples with camera, how we can use it. I'm just interested. That will be helpful. RayLib 2D camera example. Let's see what we got here. Okay, they use begin mode 2D inside begin drawing. Okay, no problem. We can do that too. But I think we need to create a camera first, right? Give me 1 second. Okay, so yeah, let's do just that. Maybe we can do something like here. Maybe for now I will comment image drawing right now, and yeah, let's begin RayLib begin mode 2D. We have to pass camera into here, RayLib and mode 2D. Okay, now we need to create a camera, right? Camera, RayLib camera will be equal to, I think just empty camera will be enough. So what do we have to set here? Camera position. Camera position. I'm not sure if we care about the Z of the position because we are making 2D game. Anyway, I do not know if RayLib rendering system is dependent on the Z. Okay, for now let's just do it RayLib vector 2. Okay, yeah. Let's just implicitly say that this should be 0, 0. What? Okay. No, I do not understand. What? Cannot assign bar. Vector 2. Why does it think that I'm trying to pass? Maybe internally. Okay, I do not understand that. Yeah, let's just leave it as it is. Never mind. Offset. What is an offset in RayLib camera? Projection. Interesting. Camera projection. RayLib or matrix ortho. Okay, interesting. Yeah, let's say, okay, left, right. What do we want to set it here to? Left, right. Give me 1 second, guys. Bottom, top, near, far. Left, right. Okay, I think we need to calculate the aspect ratio of our window. Aspect ratio will be equal to RayLib window. Okay, never mind. I thought that there will be an easy way to do this. F32 RayLib. No. Window width divided by F32 window height. Okay. Now, let's say that units units per height will be equal to 12. Okay, yeah, 12. Okay. Units per width then will be equal to units per height. Units per width. Units per height times AR. Okay, now let's say half units per width will be equal to units per width times 0.5. Half units per height will be equal to units per height times 0.5. Now, left will be equal to what? Left will be equal to minus half units per width. Half units per width. Yes. Half units per height. No. Units. I'm sorry, guys. I'm bad at typing. Okay, and. How difficult is this? Near. Let's set it to. Near plane. Let's set to 0. Far plane, let's set to 1000. What? Okay, 1 second. What does it expect? All float 32. Okay. Matrix. Okay. This match types. Units per height. Okay. Let's explicitly tell that it will be float 32. Cannot assign. What cannot you assign? Camera projection. Cannot assign value of type. Okay. Projection matrix. Okay. How do I create the projection from? I have to open some specific math? Ray math cheat sheet. Okay, let's see. Projection. Matrix ortho. Matrix ortho. It expects doubles. Why we should have provided floats? I do not understand that. Where do I take this projection which they need? Camera projection. What is it? One second. I'm sorry, guys. I'm too slow with that. RayLib camera. RayLib camera. RayLib. Camera 2D. Oh my god. Seriously? Okay. Okay, never mind. RayLib camera 2D. There is camera 2D. Holy shit. I should not do it because I think it will be done automatically. Okay, camera 2D. What should I do next? Camera target, camera offset. Offset. Let's just experiment. Camera target. Camera zoom. Let's say it will be equal to 6. Draw rectangle. Begin mode. One second. Begin mode 2D. Camera. Draw rectangle. Okay, I see. This begin mode 2D and end mode 2D are like basis change. Yeah. So basically, we should provide those parameters. And based on that, it will calculate the orthographic projection, I believe. And yeah, we will be able to draw something. Now the question, how does it do it? And yeah, let's just try to experiment. I think we will be able to come up with something. RayLib draw texture. No. Actually, no. I will try to draw a rectangle of size 1. A rectangle. Draw a rectangle. Let's try rec version. RayLib rectangle width height. Width equal 1, height equal 1. What I want to see. Really red. I will not see something because actually I do see it. I see a rectangle at the top at the top of the window. Okay. Give me 1 second to think, please. Okay, what we can do now is that maybe we should provide an offset to the camera, maybe. Let's do it something vector 2. Sheesh. Okay, 32. Height. Let's multiply it by vector 2 0505. Can we do it like that? What? No. What am I doing here? Sorry. Yeah, now our rectangle is in the middle. The reason of why it is bigger than 1 pixel is because I've set a zoom here. Yeah. Okay, what parameters do we have? Also, camera. Target. I do not understand those namings. What is target? What is zoom? Okay, let's think a little bit. Originally, everything is of size 1 pixel. If I provide 1, it will treat it as 1 pixel size, which is very small. If I want 1 pixel, if I want 1 to be like, if I want 1 to be like 100 pixels, then I have to make zoom bigger. Okay. Now. Okay, 1 second. Now I'm curious, what will happen if I increase x by 1? Okay, goes to the right, as expected. Okay. What if I increase y? Oh, I'm sorry. It will go down, I expect, yes. But we want it to go up. How do we do this? Interesting. What do we have in the cheat sheet? What do we have in the cheat sheet? All this stuff has to be figured out once, and then it will be straightforward. But because I'm learning, I have to figure all these things out. Get camera matrix, update camera. Okay. Begin mode. Camera. Not really that helpful, isn't it? Yeah. Chinese. Okay. RayLib wiki. Code. Source. Actually, we do not have to. We do not have to. Okay, look at source because I think everything we can find right here. Camera. Scaling should be 1 by default. Rotation and zoom origin. Rotation and zoom origin. Okay. Camera offset displacement from target. Not really that helpful for me. How do I make the world coordinate system to go up? Yeah, basically what I'm trying to figure out is how do I do it, like how do I increase y here and then the rectangle goes up and not down? That's the problem which I'm trying to figure out. If someone is interested. Also interesting. Okay, draw a rectangle. Yeah, it makes sense. Okay. Makes sense. Okay. Okay, 1 second. I need to think. RayLib, camera, flip Y. Рыж, привет. Привет, привет. RayLib scale F. Scale. Image color grayscale. I know. I think it's a dead end. But just in case, RayLib matrix scale. No, it's not. This is not what I need. It's weird. It's weird. One second. Okay, okay. I don't know. I don't know. I don't know how to do it because, as far as I can tell, there's no like functionality to do that. Aha. Maybe we will do. 1 second. Camera equal RayLib camera 3D. Oh, sorry. RayLib camera 3D camera. Projection field. Projection. What is camera projection? Orthographic. Orthographic. Camera up vector. Interesting. Okay. I think what we can do is that maybe we can create a camera in 3D and just say it to have orthographic projection. Though I think if we do not provide it with custom matrix, projection matrix, then it will not do what we want. Or maybe it will. Ah, no, it will not. Ah. Okay, 1 second. I will try to search for more camera-related things. Matrix perspective. Get camera, look at matrix, view matrix. Maybe let's search for RayLib examples. And maybe we will find something interesting there. What do you think? What is your goal at the moment? My goal at the moment is to make camera. Oh, 1 second. Sorry. Okay, you see, the rectangle is in the middle of the screen. If I increase y coordinate to be a higher value, the rectangle goes down. I want it to go up. I want like positive y to correspond to like up and not down. This is what I want to do. How do they work with the camera? Begin drawing, clear background, draw. They do not care at all. They they do not use camera at all, right? Yeah. They do not do any camera stuff at all. Okay. I do not want to play. I want source code. I do not want. I just want the source code, guys. I just want the source code. No cameras as well. Ooh. Okay. Nothing useful. What if I search for projection? Nothing about projection as well. Okay. I don't know what to do. I don't know what to do. That's kind of stupid. Why am I not able to do that? idea. Yeah, let's Google one more time. RayLib camera Y. Maybe I'm missing something. Drawing related cursor. Maybe you can just flip the coordinates by yourself. Screen height. Let me think about it. One second. Actually, I think it is a good idea. We can do it just before passing into here. Yeah, good idea. Thank you very much. Yeah, I was not thinking about this at all. Yeah, what we can do, rect to draw. Let's say it will be equal to this. Now, we can create a function, something like RayLib. One second. Project vector. Project point. Let's say we will have camera as a parameter. RayLib camera 2D. And we will have a point. RayLib point is of type RayLib vector 2. Good idea, Rish. Thank you very much. Okay. Sorry. It will return RayLib vector 2. So, what our goal is? We do have a point. Okay, one second. I need to think about it. So. One second. One second. Yeah, I need to think for a minute. Okay, I want everything to be expressed in like meters, not pixels. And And to do this, I will not even use this camera. I think I think I don't need it. So yeah, what I want to have is some context about what am I trying to do. And I think the things that I will need is just pixels per unit. Let's say it will be 432 equals 100. Okay, that will mean that for each like imaginary meter, it will mean that 100 pixels is 1 meter. Yeah, that's it. Okay, pixels per unit. Okay, also I will need some camera zoom. Or maybe I can call it camera radius. I think it will be better. It will also be float 32. Yeah, and let's say it will be equal to 6. What that one mean is that like half of the screen will be okay. Okay, 1 second. Okay, if we are at the center of the screen, I want it to be so that from the center of the screen to the upper, like upper part of the window, I want this distance to be equal to 6. This will be camera radius. Okay, I think I will need this one, and let's say camera position will be equal to, oh, maybe we can use Odin's maybe we can use Odin vector. Maybe let's try to use it. I've never used it. No, it is not math. It is core math. Linear algebra. Yeah. Let's say it will be so many vectors. Okay, never mind. Yeah, camera position will be equal to what it will be equal to. Oh, okay, let's say it will be 0 for now. And I think the last missing thing is screen window width and window height. I think we will need that. So yeah, I will create a struct which will be like my own camera. My own camera stuff. I will put all of these into here. I cannot assign default values in structures. I'm wondering why Ginger build did not make default values in structures. That question is interesting to me, actually. Screen size. Vectors are just arrays. Yeah. So basically I create those vectors as arrays, or what? I'm wondering then, maybe then when I want to do some operations on those vectors. Interesting. Actually, let's try to use them like as arrays. Interesting. I'm just exploring how can I do some stuff in this language, because it is very exciting when you learn a new language. Yeah. So let's also create a function. Yeah, let's create a function which will return me a camera, a default camera. Let's say init camera is a procedure which will take width and height as floats. Okay. Then I will create a camera. Pixels per unit will be equal to 100. Camera radius, let's say it will be equal to 5. Camera position, it will be just equal to 0 vector. Everything is default, is 0 by default. And screen size is equal to width and height. Nice. Let's, I need to return the value. Okay. Return cap. Nice. Oh my god. I don't know what would I do without you, Rish. Seriously. I was out of ideas, and now I have the idea. And yeah. So let's create our camera. Okay. Now, what I want to do is that I want to somehow do what? I want to project. One second. I just need to think about it. It is easy math. I just need to figure this out in my head. If we now want to draw a rectangle of size 1 on the screen, it will be like 1 pixel at the top of the screen. We cannot even see it. It is very small, I believe. Let's say size will be 100. We cannot even see it, or what? Second, I need to verify. Oh my god, I do not understand this. Because I'm stupid. Because I'm not I'm not calling anything to draw the rectangle. Draw rectangle rect to draw, and this will be RayLib red color. Okay. Okay. Now if I say size will be 1 at the moment, it will be 1 tiny pixel which I cannot even see, to be honest. I will be able to see it if it will be of size 10 maybe. Yeah, but my goal is to basically convert this to be of size 100 pixels at the center of the screen. So basically my goal is to convert let's say 0.00 to be the center of the screen. What do I have to do for this? For this, what do I have to do? Let's think about it for a second. I will change this function to be camera, to accept my camera, not the RayLib camera. Okay. And what? My cats are fighting. Yeah. So what do I have to do for this? It is actually very easy to do at the beginning. Okay, 1 second. I need to come up with the equation. I'm always. I will do it in a Scratch file. Yeah, as a plain text. Almost. Maybe actually, like you just said, with one exception, maybe. Only with one exception, I think. Okay, so the math here is the following. I want to multiply my input x by some value a and then add some b, some offset b. And let's say this is at least how I was always thinking about like all those computations. Y is the same, like y times say q plus w. But yeah, if we focus on x, I think it will be enough, because for y the equation will be almost the same. Okay, 1 second. 1 second, let me think about it. So My brain is not working today at all. If I pass like 0, if x is 0, I know that I want this x to be at the center of the screen. Like width divided by 2. Times a plus b. So from here we can say that b is equal to width divided by 2, because 0 times a is 0. Okay, and then if we do what? If we say, if we, for example, multiply 1 by a plus b, we want it to be equal to width divided by 2, but plus this pixels per meter. Pixels per meter. Right? Because 1 meter is 100 pixels, right? But this is not everything as well, because that is not all. That is not all. Also, we need to count for the zoom of the camera. For the zoom of the camera, right? And how we can do it. We need to divide this by camera radius, if I'm not mistaken. Yeah. Aha, and I'm sorry guys, that is not all actually yet, because I think camera, we need to account for camera position as well. Camera position. We need to account for camera position. If our camera was a little bit to the right, we want to shift X to the left, right? Yeah, and so I think we need to where should we do it? Pixels per meter. I think we need to do it before we divide. Before we divide, because I think that will be accurate. Pixels per meter plus minus camera position X. And now we know this b, because we've calculated that b is equal to width divided by 2. If I'm not mistaken, right? Yeah, I just hope I just hope that I did not miss anything, and it looks like I missed something, because width divided by 2, and if we have width divided by 2 here, they will cancel each other out, and I do not think this is accurate. some reason. 1 second, 1 second, I need to think about it. This is very interesting. I like to solve such problems, actually. 1 second. I just want to make sure that I did not miss anything here. Let's figure out this step. If the x is 0, I want the position to be at the center of the screen. At the center of the screen. 1 second, please. 1 second. That one looks correct to me. That one looks correct to me. Okay. Okay. Let's just say that I think that this is correct. What does it mean then? It means that A will be equal. A will be equal to what we have here, pixels per meter minus camera position x divided by camera radius. Okay. Okay. Okay, maybe actually everything will be correct. So let's I forgot the shortcut. Never mind. I will not even try. I forgot how to split the window down. But at least I remember how to split it to the right. Okay. So we have a point. I think I will create a new point. U P. I will just call P. P will be equal to okay, this becomes very interesting. Camera pixels per unit minus camera position. I think I do not need to repeat myself here. This is stupid. Camera radius, camera position, camera position x. Okay, this all divided by camera radius times input point x and plus camera screen size x times 0.5. Okay, I think, I hope, at least I hope that this is correct. But for y, For y it will be a little bit different, I believe, because we do not want to increase. We do not want to increase. We want to like subtract. See, if I let's do it from the beginning for y. Y equal to y input y times a plus b. So if it will be like this for 0y, right? 0 times a plus b. B equal to height divided by 2. We can put it here. But what we can also say that 1 times a plus b in the screen in the screen coordinates, it will be equal to what? It will be equal to, first of all, height divided by 2. I need to subtract. I need to subtract from here. Yeah, I just need to subtract from here all the same. Pixels per meter minus camera position y divided by camera radius. Yeah, I just hope it makes some sense. So I think a for y, a will be equal to pixels per meter minus camera position y divided by camera radius. Yeah, that's it. Aha, no, 1 second. Minus here. Yeah. Camera pixels per unit minus camera position y divided by camera radius times point y plus camera screen size y times 0.5. Yeah, I think that's it. Okay. It will not be RayLib vector 3, it will be something like that. Missing type in the compound literal. What? Ah, okay. Okay, and yeah, the moment of truth. Like I just I need to convert. I need to write my own draw rectangle function or what? I think, yeah. I think I will have to. One second. Okay, never mind. Let's just test it. Let's say we have yeah. So basically, we are projecting from world to the screen space. So I don't know, let's say we have world, like world P equal to, I don't know, equal to 1, 1. Yeah, maybe it will be just a wrapper or above the existing function, but to test what I've just written, I think I do not need those at all. I think I can just call the project point camera. And the point that I will pass in will be world P. Okay, now I have to convert. I will just make a small point, small red point, helper point, which I will try to draw at the position screen P X, screen P Y. It looks okay. 1 second. Test draw P world P. Camera, and say point. Yeah, point. I want to specify this type like this. Maybe even like this. I think those types are the same, but I like I do not like to write this F32. Yeah, I think it will be the same. So basically what I need to do is that maybe if you are using camera, seems like it meant to be used. Yeah, I've been using it like this. Yeah, I did just the same as you just told. But it was not working. It was like pointing down. When I've been showing you how it worked, I've showed you with this begin end mode enabled. Okay. And I need to draw screen P. Okay. Let's maybe provide the color parameter. Okay. Change the color and what? Yeah, let's just call test draw P a few times. Camera point. But let's provide it with 0, 0 point, and let's say that at 0, 0 color will be green. Yeah, I think we need to choose another color because green is quite bad for this. Let's say blue. test draw world B, let's say camera. Let's say x will be 1, but y will be 0 still. RayLib. Let's say the color will be RayLib red. Okay. It makes sense. Okay, it makes sense. Or not. Yeah, I think it makes sense. Okay, and the last one. Test draw world B. Camera. Let's say x will be 1 and y will be 1 as well. Let's say RayLib black. Yeah, everything works as expected, except one thing. I think either one of those is not needed. We either do not need pixels per unit and radius, because basically those are just the same. They try to do the same thing. They try to scale like, yeah, that is stupid. I believe it was. Yeah, I think I can just safely remove those and just leave camera radius. Yeah, I think this will be even better. Or not. One second. Initialize camera pixels per unit. Now everything is drawn at a single point, and I think I understand why. This is because camera position is now 0 divided by 0 plus point times point x. Interesting. Okay, I did not expect that, but that's logical. That's logical, okay. That is logical. Oh my god. What am I missing? One second, please. Okay, one second. I think I know how to get around this. 1 second. Yeah. Instead of this, let's do what? Let's do the following thing. Let's create two variables. Half width, half height will be equal to camera. 1 second. Half size equal to camera screen size 0.5. Okay, then here camera screen size x. No, 1 second. half size x, half size y, and here will be, yeah, if I want to get rid of those pixels per unit, I need to put something here, and that something will be that something will be 1 second. Interesting. I know, I'm sure that this will work, but this will look weird. Prepare, guys. Half size x divided by camera radius. I said weird because I divide by radius 2 times. What? 1 second. I need to think about it. No. Oh my god. Oh my god. Yeah. This is weird, but I just need. I just need a few seconds. Okay, never mind. No, just to prove myself that I was correct, I will finish that and then return back to what I've been using, because actually right now I think that this is not a bad idea actually. 1 second. It works correct. It works correct. Divided by camera radius. I'm intrigued. It will work on first run. It will work on first run. It will work on first run. Yeah, it works. Yeah, but I do not like how it looks. Yeah, I just do not like how it looks. Yeah, I need 1 second to think about how to make it look good and never return back to it. Yeah, so the bad thing here is that I just repeat myself, and it looks the same as it was before, which I was surprised to see. I think this is because of this division. I think. One second, please. Okay. I'm thinking now that it was actually a good idea to do it this way. For some reason, I still think that those both were like redundant. I just need a single one of these. Okay, I will just try to do it. I will just try. Yeah, this looks like I was thinking it will look. The only thing is that now I'm not sure if we account for this correctly. Actually, we can test it easily. What if I just say that camera position equal to equal to 1, 0. 1 on x, 0 on y. Let's do it this way. What's the problem? A variable declaration must be an identifier. Ah, okay. This does not look correct because I've like moved my camera, but it didn't move at all. And let's think why it happens for a second. It happens because this pause, because we've subtracted basically 1 pixel. Yeah, we basically subtracted 1 pixel. 1 second. If we return back to this equation, I think we can figure out something here. It will be easier, maybe. So, if I put 1 instead of x, then I want it to be like width divided by 2 plus, we do not have pixels per meter now, we only have this, But that's not enough, because camera position X should be somehow correlated with the scaling. Related with the scaling. And what is the scaling? The scaling is yeah, I just have to multiply it by 1 second. I have to multiply it by width divided by 2 with no, 1 second. Yeah. I need some value. I need some value. Yeah, it will. Yeah, I need some value. For example, v, which will be equal to height divided by camera radius. Yeah, and then I will have to multiply it by v divided by cr. Yeah, I think that should work. No, multiplied just by v. Just multiplied by v. Yeah. So yeah, I think it will look like this. I hope I'm not mistaken once again. Yeah, I hope I'm not mistaken. But yeah, 1 second. Camera position, half size. Yeah, let's just calculate this. V is equal to half size H, half size Y. Yeah, I'm sorry. How it should be like this. Half size Y divided by camera radius. Oh my god. I think I'm close. I think I'm close to the correct equation. Now, yeah, just let's rewrite it. Camera minus camera position X minus camera position Y times V times V, and that everything divided by camera radius. Why we do not see the vertical one anymore? And why they are again so close to each other? Aha. This is because camera radius. Although it is 5. It is not that big. 1 second. 1 second, please. Like if I divide it by 5, how much it will be? Like it should be quite big enough. 1 second. I'm missing something here. Definitely, I'm missing something here. Okay. V is equal to this thing. Height times 0.5. Height times 0.5 divided by camera radius. Okay, that looks correct to me. Yes, that one looks correct to me. Now, okay. Let's just go through our computations. Like if camera position X is equal to 1, right? I want like everything to be shifted to the left. By how much? I want everything to be shifted to the left by... I do not need to divide here. I do not need to divide here. Block T. James. Hello. Yo. Yeah, this one I think I like more, but where's the vertical one? Blue, red, black. Where's the red one? Where is it? Where is it? I have no idea. Where could it disappear? 1 second. 1 second, please. Screen P X, Y screen P Y. Yeah. Everything looks correct to me. We are drawing 3 points. Blue one to the left. Red one should be... 1 second, what? What? How is that possible? blue one has to be to the left. And black one has to be to the right. What? What is going on? Okay, I need to go through it once again. I need to go through it once again. Okay. So minus camera position X. Aha. No. Hmm. Mhm. No, 1 second. Ah. Okay, I will remake all of this once again. If my x that I pass in is 0, then after such computations it should be width divided by 2, right? So from here we know that b is equal to width divided by 2. That's absolutely correct. Then, yeah, no doubt. This is correct. Then, for how do we calculate a? Then, so yeah, if we pass 1 and multiply it by a plus b, we know that b is width divided by 2, so we want it to be width divided by 2 plus what? Plus v. What is v? What is v? V is equal to, as we've calculated, v is equal to half height divided by 2 divided height times 0.5 divided by camera radius. Okay, but that is not all yet. We need to account for the camera as well. We need to account for the camera. Do we really need a camera 2D? I mean, if so, begin mode 2D should work. Just some misunderstanding. We may explore RayLib examples on this topic at the RayLib GitHub. Yeah, I've been exploring today, and I didn't find a way to tell it so for y coordinate to be up, only down. Yeah, that was unfortunate. No, I'm really close. Like I'm super close. For already 1 hour or so. Yeah. So v minus what? minus camera position camp x times v. Yes, we can then do it like this. Yeah, finally. Oh my god. V times 1. Yeah, I like, man. Like, man, I just hope that it will be correct. This should be. Okay. But where is the blue one? Oh my god. For some reason we only see like everything on x that which is lying on like 0x. Sheesh. Yeah, so what? A is equal to v times 1 minus camera position x, right? Like, I mean, for y it looks correct. For y it looks correct. Absolutely correct. The blue point has to be here, but it is not. I mean, maybe I should just print the coordinates, the resulting coordinates. Maybe it will help. FMT print ln print b. So 3 points. For some reason, I have 2 points in the same place. How is that possible? Okay, 1 second. Yeah. Like do FMT. Let's do FMT print. FMT print input position, world position, right? FMT print space. FMT print ln print this FMT print and apply. So, what do we see here? We see that for it did not calculate correctly for x. It did not calculate correctly for x. Why? Let's compute. Let's just try to compute by hand. If we pass 0 into here, what will happen? 0, 0. Okay, it will be 0 because if we multiply by 0, we only have this half size x. Yeah, it will be the center of the screen, 960. But if we pass 1, what happens? If we pass 1, v minus camera position. Aha, camera position is 0. Oh my god. No, camera position is 1 right now. So I'm doing camera position stuff correctly, right? Oh my god. Oh my god, I know. I was always thinking that this part is correct, but it is not. Because the reason of why it is incorrect is that when we if the camera moves, the center also moves. Sheesh. Oh my god, man. Minus. Yeah, so I have to account for camera position here as well. It will be what it will be equal to. What it will be equal to. How much should I move to the left? I need to move camera position x. Camera position x. Multiplied by v. Can't be x. Oh my god. I feel so stupid. I feel so stupid. Give me a second. So B will be equal to what? One second. What is going on? Where did it disappear? Oh my god. Yeah, so B minus camera position comp X multiplied by V, but this means that this computation has to be adjusted as well. Okay, we know that we use this one, so plus B. Plus B. Okay. Yeah, so basically what do I have to do now? To calculate A. What A will be equal to? A will be equal to width divided by 2 minus B plus V times 1 minus camera position X. Finally, yes. So yeah, half size X minus B. B is equal to what? Is equal to half size camera, 1 second. Campy camera position X. Okay. Plus. Because with minus B, it will be equal to camera position X times V plus oh my god. It makes Боже мой. Okay. So for me, it's been always too easy to do such computations. I don't know why it takes why now it takes so much time. It is such an easy task. Why it takes so much time to do for me? I'm old now, probably because of that. Anyway, I will finish it today. I will do it because it is not really that difficult. The thing that I'm interested right now is that if I do minus B here, what it will be equal to? Minus B, it is just the same as typing this minus camera position X times V. But the problem is, this cancel each other out. Camera position times V only left. And now the problem is that camera position X times V minus camera position X times V, and I leave only with V. A cannot be equal to V. Ah, it can. It can. It can. Oh my god. It can be equal. Yes, yes, it can be equal to V. Of course. Of course it can. Shush. Half size. Oh my god. But I'm happy. I'm happy that I'm happy that I had to spend so much time on this just to come up with such simple equation. Ah, sheesh. How difficult it was, man. Campus y times minus v plus half. Minus half size. Or what? Wait a second. Plus half size y times what? No. What am I doing? What have I just written here? What the heck? No. Point x times b. Half size plus half size x plus v. I will write it here. So, yeah. A is equal to V. Yeah, but B is equal to half size X plus V times camera position X times V. Okay. Here is the same. Plus minus camera position y times v. Cross my no. One second. Point y. Yes. Oh, wait a second. We almost did it. It should go to the left. No. We are so close. Yeah. Wait a second. Okay. Yeah, it should go to the left, man. It should go to the left. Why is it going to the right? Oh my god, we are so close. One second. Please. Okay, one second. Maybe I've missed something here. Maybe it is possible. Wait a second. What is this stuff? Okay. B. The only thing that I'm not sure is A. Wait a second. A plus B. I will once again rewrite it. Yes, but if I subtract if I want to calculate A, I need to move B into here. So I need to subtract B. Wait, oh, sorry. I need to subtract B. Okay. B, we do not have B. So those cancel each other out. Okay. We are left only with this one. With this V. If I remember correctly, here should be a plus. Yeah. So yeah, those cancel each other out. Because minus on minus gives plus, okay. And yeah, V times camera position X. So those cancel each other out as well. And we are left only with V, right? Correct. So A equal to V. And that makes sense. If we think about it, it makes sense. Because we scale our input position by V. Oh my god, how did I not come up to it quicker? No, Rish, you should not throw water because it looks almost correct to me. It has to go to the left, not to the right. Yeah. Plus half size X. Oh my god. Why did I do plus here? I should do minus because we want to go to the left. Correct? It's on Y where I have to do plus because if I want no, wait a second. I need to think about it. Yes, correct. This is correct. Yes. Oh my god. Finally. Yes. Oh. So yeah, if I move my camera to up. Oh, sorry. If I move my camera, for example, 4 units up, those should be now at the bottom. Yeah. Yeah. Finally. Yes. Quick math. Quick math. No, it's about me. It's about me. I'm really quick at math. Yeah. So finally, oh my god. So yeah, finally I have this function complete. I mean this function, project point. Okay. So I hope now it will be quicker. I hope now it will be quicker. I hope. So yeah, what I want to do now is that I want to be able to draw images at the specified position. Images at the specified position. I do have, what do I have here? I have draw texture. Okay. But this is all in the screen space. This is in the screen space. If I want to be able to move with camera, right? I need to be able to draw the texture in the world, like in the world, because my camera lives in the world and not in the screen. Yeah. Okay. This will not be difficult to do, I believe. First of all, let's just let's just think about how big we want like our texture to be. Like, let's say it will be 20 meters by 20 meters. Or no. Or no. Ah! Yeah, I know how we will do it. Image. What does RayLib image contain? Image. Okay. So yeah, to draw the image in the world, let's say we will have a function draw image in world. It will be a procedure. It will take camera. It will take RayLib image. RayLib image. What else? It will take position in the world. The position in the world. Pos will be equal to RayLib vector 2. And maybe, let's say, color. RayLib color. Okay. So we need to first build a rectangle for this image. RayLib draw texture rec. Draw texture rec. Draw texture rectangle. Okay, we will have to build a rectangle for the image. RayLib rectangle equal to okay, and we will have to compute those. What options do we have here actually? Draw texture B. I think draw texture rec will be better. for us. I think we will have more options. For now, let's just say that I want something like this. I do not want to care much about the correctness of that. Okay, I will do it the most brutal and the most inefficient way, but I will do it. I will convert my image to texture, right? Maybe even not like this. Maybe I will pass texture, RayLib texture, like this. Okay. That's unfortunate that I do not have width and height here. RayLib texture. I thought that maybe it will be possible to somehow get the width and height from this RayLib texture. But never mind. I will figure something later. I'll figure something out. Yeah, so yeah, what do I have to pass here? Which parameters? Texture, rectangle, position, and position. This has to be in screen space. Pos screen equal to, let's use our function project point position. And camera, of course we have to pass here. Position screen. Position screen, and the last one is color. Oh, can I pass default arguments? I'm just interested. RayLib white. Let's say map texture. RayLib. Let's say it will be equal to RayLib texture from image. Map image. Okay. Now I will not draw the texture the old way. I will do it the new way. Draw texture in world. Draw texture in world. Camera. Map texture. Position. Let's say at 0, 0. I don't care for now. I just want to see something on the screen. Oh my god. 1 second. I wanted to put it into here. Okay. Rectangle. let's reset our camera to 0, 0. I do not see any image though. Begin drawing and drawing. Map texture, camera, rectangle. Oh, sheesh. Texture loaded successfully. Default shader loaded, unloaded successfully. Okay. Draw texture rectangle. I'm wondering if I did everything correctly. Position on screen, on the screen. Position. Let's print out this position on the screen. Yeah, it is correct. I do not understand then what this rect is. Raw texture B. Aha. Yeah. Or no. Okay, 1 second. Draw texture rect. Rectangle. Okay. Why don't I see? Because rect is RayLib structure with pos x plus y with height. Yeah, I know. I know. I've been expecting. Maybe I do not understand what this function does. Draw texture rec. Aha, draw part of texture. Defined by rectangle. Ah, oh my god. It is not the whole texture, it is only a part of that texture. Can I scale? Draw part of texture defined by rectangle with pro parameters. Scale. I see it. X. I do not need rotation. Yeah, I mean, which parameters does this function have? Position, pause screen. Rotation 0, scale. Scale is an interesting part here. Scale is an interesting part here. And why do I say this? This is because we need to compute the scale based on the camera. This is because we need to compute the scale based on the camera, and I will do it in a moment. Okay, we need to do some math once again. We need to do some math stuff once again. This should be quite easy. I hope. So basically, I want for textures, I want this metric called pixels per meter. It will be equal to 100. Also, what I want. So yeah, I need to scale based on that. Based on that, I need to scale. One second. Actually, maybe I do not need this. 1 second. Please, 1 second. No, I think I will have to have it. So yeah, what the scale is. Okay. Meters. Okay. I need to somehow get the width and the height of this texture. Somehow. I do not need how. I do not know how. How do I do this? Maybe there is a function. Texture to D. Texture data stored in GPU memory. You know what? I will pass image into here as well. I will pass image into here as well, and yeah, I will just have to map the image, put it into here. Also, yeah, I need to compute the size first. Maybe there's a function get image. No, there is not. Okay, image. Please don't tell me that I cannot get width and height of the image. I have to do it, man. Oh my god, no. Why? Get RayLib get image size. Use image width, image height. Really? I can do it? I hope I can. Image size equal to vector2 f32 image width, 32 image height. Where's this image? RayLib image. Okay, I can, because otherwise it will fail to compile. Okay, nice. Image size. I have image size. Okay, now let's say half image size will be equal to 0.5 times this. Now no, which I do not need this half. Let's say now meters per meters size will be equal to RayLib. No. Image size divided by pixels per meter. Okay, now we have our size in meters. Now we know our size in meters. Okay. If I know the size of an image in meters, what I can do? How do I compute the scale? Because, like, one second. Originally, the scale is 1. If I want to convert the size like of from pixels to meters, like I need to divide. Okay. Basically, if I'm not mistaken, the scale has to be 1 over pixels per meter. Not like this. I've expected it to be a little bit bigger. Okay, let's say that the position on the screen will be equal to 0. Yeah, Okay. Yeah, so what I'm thinking is that I will do some kind of alignment. I do not want to draw the image from the top, top left corner of the screen. I want it to be drawn with some custom alignment. Let's say that for now, alignment will be equal to 0.5 on X and 1 on Y. Okay. So basically, if I have the point, the screen, the position on the screen, I need to say that the position on the screen will be equal to project point minus image size times alignment. I'm not sure if I need this at the moment. Okay. Pause screen. Okay. 0 is rotation. Scale. Let the scale be 1 at the moment. Yes. Okay. Now I can like move my camera. It is cold for some reason. I will put my socks on. Okay, I'm back. So yeah, I can draw texture. I basically, let's do some input stuff, interesting input stuff. Let's say if RayLib key is key down. Key A. Let's say that I will move my camera to the left. Camera position X minus equal speed. Oh, maybe we'll put, let's say camera will have speed, which is float 32. And let's say that the speed will be equal to 1 meter per second. Okay, camera speed times delta time. I need to get delta time somewhere. Get frame time. Nice. Okay. If RayLib is key down, dot d camera position x plus equal to camera speed times delta time. If I will just copy paste. Why if I press S if I press W, yeah, good job. Nice. This is what I wanted. I'm wondering why RayLib developers didn't make it to be an option in their library by default. Okay. That is something. Okay. Good job. Now, maybe let's do some scrolling. Maybe. 1 second. Why not? We can do it. I do not know how, but maybe we will figure this out. If RayLib scroll mouse get mouse wheel move. Get mouse wheel move. Nice. Okay. Now wheel. Move. Okay. Let's say that camera target radius is equal to camera radius plus target radius plus real delta. Now camera radius let's say that we will lerp from camera radius to camera target radius delta time times 5. Okay, I see that the camera scale is working, but the image does not count for the camera scale. Okay. It's not a problem, I believe. Okay. So I need to figure out the scale based on the camera zoom. And actually, I think now is the moment to finally do this pixels per meter. Pixels per meter is 100. So yeah, how do I compute the scale? How do I compute the scale? Okay, size meters equal to RayLib vector to image size vector to image width image gigahertz. Okay, image size meters equal to RayLib. No, equal to image size divided by pixels per meter. Okay, now I have the meters size of my image. The meters size. Now, okay. Okay, somehow from this I have to compute the scale so that it corresponds to the scale of my coordinate system. How do I do it? How do I do it? My image is, let's say it is like 20 meters in width. 20 meters. The original scale of the image like is one second. To compute the scale, I need to know like two things: which size was originally and which size it has to be displayed currently, right? Which size in meters it was like originally. Originally it was image size meters, right? Which size has to be displayed currently at the moment? How do I compute it? How do I compute it? One second. Okay, here we have this V. And I think if we multiply this V by the image size in meters, then we will get, yeah, I think that's correct. Okay, so image size DST destination is equal to image size. No, one second, sorry. Okay. Image size meters. I still have to do it. I still have to divide image size divided by pixels per meter. Image. Okay. Oh my god, sorry. Destination image size equal destination image size is equal to image size y times 0.5 divided by camera radius I have to multiply image size meters by that if I understand correctly. The fact that I have to specify types all the time is quite a little bit annoying. Okay. Yeah, and now I one second. Scale. Image size. Okay, it works, but the only thing is that I need to account for the scale when doing alignment. Right? I have two image sizes. They are the same. Nice. Where's the alignment? Where did I do it? Align. Will it just work if I multiply by scale? Yeah, it works. I did a random thing and it worked. Yeah, nice. Good job. Actually, it's okay. I don't like the fact that it should be very fast. I don't know. Maybe I'm mistaken. Maybe. Why is it so smooth? I don't know. Okay, what I want to make sure is that we never divide by 0. That this camera radius is never equal to 0. Is never less than 0 as well. Camera. I have heard lerp something. Is it like an easing? Some kind of easing? Yeah, exactly. Maybe the next time I will explain it in detail if you want, Rish. It's cold for some reason in my room, and I feel bad. I feel like I have to go eat something and drink some tea. But yeah, I want to finish some things as well. I'm wondering, how do I find the math? Import core math. Math clamp. Nice. I want to clamp camera target radius. I want, let's say, camera radius at minimum be equal to 1 and at maximum be equal to, let's say, 10. This is just for testing purposes. Nice, nice. Good job. If you want, Rish, I will explain this LERP stuff to you the next time if you want. Yeah. Okay. I still think that. Oh my god! I still think that in RayLib there may be an opportunity to do like what we did today, but I'm maybe too stupid to to be able to find it. Yeah. Okay, what I can do here. Okay, I wanted to make today, like start making some kind of a Worms game. I want to be able to destroy this part of the nature, this piece of nature, by using some weapons or anything. Yeah, so I think in the future episodes, videos on future streams, I will continue. I will continue implementing some features. Maybe tomorrow, most probably tomorrow, actually. Um, I will continue implementing features. Maybe we will make the destruction of. I don't know. Maybe we will drop some projectiles and when they collide, maybe we will do some collision detection. And on when the collision will happen, maybe we will like um, destroy some pixels or anything. You know, I think we can have fun of it. Yeah, yeah. Not too much has been done today. Not too much, but anyway, I'm quite happy with how it turns out. Keeping in mind that I'm trying to learn Odin, that I'm new to the RayLib. Yeah, I think we've done great today. Yes, so thank you very much, guys, for those of you who've been watching. Rish, thank you a lot. One another guy appeared today in the chat. I don't know if he's still here, but the stream counter shows that there are 3 viewers on the stream, and yeah, one is me because I have a laptop. I have a laptop here, and I watch the stream and I read the comments. One is Yurish probably, and yeah, and someone else. But anyway, thank you very much for watching, Rish. Yeah, see you soon. Goodbye. Goodbye. Have a good evening. Have a good end of your day. And if I will stream tomorrow, you will see. Goodbye. Пока.